Conversion of nuclear energy. Basically, a nuclear power station and a coal-fired or a natural gas power station are very similar in terms of power generation principles and major facilities. They all make use of heat from their fuels to create steam that turns the turbine and enable the station generator to produce electricity. The main difference is the kind of fuel used. So nuclear power is generated mainly through the use of uranium. The process to produce heat in a nuclear power station is called fission. The fission generates heat in the reactor and heats up the water surrounding the fuel rods. The water will then be changed into steam to turn the turbine and enable the generator to produce electricity. So commonly used nuclear reactors. The power generation in all nuclear reactors are based on nuclear fission, but the design of reactors may be different. The commonly used reactors type in the world are the pressurized water reactor, boiling water reactor, and pressurized heavy water reactor. So in addition to these three widely used reactors, there are other types of reactors, other commercial operation in nuclear power station worldwide. They include gas-cooled, light water, graphite, and fast neutron reactor. So let's discuss the first commonly used nuclear reactors, which is the pressurized water reactors. So PWR is the most common type of nuclear reactor, representing about 60% of all nuclear power reactors in the world. PWRs are adopted in countries such as US, France, Japan, Russia, and China. So these use light water or ordinary water for neutron moderation. The reactor heat removal, the water inside the primary cooling circuit of PWR is under high pressure, and it will not turn into steam even under high temperature. The primary circuit and the secondary circuit are completely separated, and heat energy will be transferred from the primary circuit to the secondary circuit. With a lower pressure in the secondary circuit, steam is raised to drive a turbine generator to produce electricity. These reactors use uranium-235 of a typically 3% to 4.5% enrichment. PWR's two cooling systems separate the reactor, cooling water, and steam for power generation. In the event of necessary venting, steam release will be free from radioactive products. Boiling water reactors. So using uranium-235 of typically 2% to 4% enrichment and account for around 20% of the nuclear power reactors. BWRs are adopted in countries such as the US, Japan, and Sweden. BWRs use light water for neutron moderation and reactor heat removal. The heat raises steam directly in the reactor pressure vessel to drive a turbine generator to produce electricity. BWR's basic design is similar to that of PWR, except that it uses only one single circuit, in which the water is at lower pressure, as the water around the core of the reactor always contains some traces of radionuclide should necessarily venting occur, any steam release could contain radioactive products. Pressurized heavy water reactors, usually referred to as CANDU. PHWR was developed in the 1950s and is widely used in countries such as Canada and India. PHWR represents about 10% of all nuclear power reactors in the world. This type of reactors uses uranium at its natural level of around 0.7% uranium-235 concentration with no enrichment. It uses heavy water for neutron moderation and reactor heat removal. Heavy water absorbs the fewest neutrons among common moderators materials so that it will least suppress the chain reaction. This heavy water flows inside the pressured tubes filled with uranium, taking away reactor heat and delivering it to an adjoining circuit to raise steam and drive a turbine generator for production of electricity. PWHR's pressurized tube height design enables refueling of the reactor during operation by isolating individual pressure tubes from the cooling circuit. Comparison between pressurized and boiling water reactors. Both pressurized and boiling water reactor use enriched uranium as fuel and water as both coolant and moderator to slow down neutrons. The major difference between these two types of reactors is PWR has water at over 300 degrees Celsius under pressure in its primary cooling heat transfer circuit and generates steam in a secondary circuit, while BWR makes steam in the primary circuits about the reactor core. Moreover, with PWR, the primary circuit to take reactor heat by water under pressure to the secondary circuit. The secondary circuit to raise steam for the turbine steam condensed as water is returned to the steam generator. While BWR, a single circuit to take reactor heat and raise steam for the turbine. Steam condensed as water is returned to the reactor. Now try this one. So give the advantages and disadvantages of using nuclear power as our source of electricity. So do some research, reading articles or journals to have some insight with this topic.